Tasty Basic Architect. Yeah, we are out here somewhere in Norway visiting I believe this is a two-family house. So it's separated by a garage. You have one over there and then one over here. You can see the windows. It's interesting. They use the metal sill pans, which I can certainly appreciate. It's got the little end dam there. As we come around here, see that trim fits nice and neatly. Just basically splits it there. But a couple of things I don't like is exposed hardware on that window. You can see it there. It's fully exposed, although there is a little flexible gasket there. I'm assuming that's to stop wind-driven rain getting pushed up into that sill. The outside is that Nordic pine spruce, but what they've done here is pretty interesting. You can see in between the windows, not top and bottom, but left and right, this middle section here, they've actually changed the pattern or density of the shiplap. It's about half there, and then it expands again to the wider. So if you go down here, you can probably see it. If I zoom in there, you can pick up the denser pattern in between the windows. Pretty interesting. But this is that treated lumber. If left alone, I'm told it's just going to gray out to that kind of driftwood gray. Done some interesting things inside. First of all, everything here is just exterior gypsum board. It is put on, you can see there's a kind of double lap rain screen. So you have the vertical that's tied to the studs inside, and then you have the lateral there that's picking up all the siding, conduit. I mean, a lot of this construction is stuff we've seen in some of the other videos. And then of course the L-shaped, it's kind of more of a rodent screen than a bug screen, because bugs can get in there. There's some interesting things happening inside here as we go in. First thing to note, everything is pretty much framed 24 inches on center. You do some funky things, and they do things a lot the same. This is, you know, a little thicker than normal piece of wood. That's probably a little over 1.5 inches there. Exterior demising wall. They do the California corner in there, you can see, and they do the double top plate here. They're using an engineered floor joist. Those are the first time we've seen those, but this is a pretty interesting detail. Over the windows, they chose to do an open header, meaning the structural piece isn't in there. They're using that for insulation. And then you can see they have a structural rim board. But the structural rim board, they don't want to use joist hangers. So then they create this little detail here where they basically ledger lock a 2x6, and then they notch the floor joist, and then they have to reinforce the floor joist with about a, it looks like it's a 3/4 inch plywood, and that's on both sides. You can see that. So rather than putting the header in the wall to aid in insulation, they push it up there, but then that creates the ledger and that additional detail. And the same is over the door here. See the door? And then it is exactly the same detail. Notice the ledger goes out over the double king. And notice, because they do that, there are no cripples added to the inside, but there's also no jack, because the two kings are holding up the header, which is that band joist. Now, if we come down the wall here, over the door, it's the same detail, but over this window, this one actually gets a header. Now, you might ask, why? Why did this one get a header and the other didn't? And you can see it's a double jack and a tall king. And I think I have the answer for you. Notice here, 2 foot on center floor joists. Notice here, 12-inch on center floor joist. So the density is 2x floor joist in this area. Now, what do I think that's happening up there? Well, I think it's pretty easy to tell. There's a few large waste pipes. So I'm assuming there's bathrooms above that with large format tile, and because of that, the floor joists had to get closer together to provide a stiffer floor so that you could actually put that large format tile and install it in confidence. Coming through the building here, this wall here is a bearing wall, and the way that I can tell that is the fact that it actually has a header in it where we have the opening, but also notice it has squash blocks on each side of the floor joist. And that is so that when you have this vertical, say, crushing load on the bearing wall, that aids, that web of the engineered floor joist is not designed to be a structural column, if you will. So notice here too, they do take advantage of the luxury of drilling holes in their engineered floor joists, and I know a lot of people are in fear of that, but remember, in the middle here, these floor joists are acting more in bending than they are in shear, so the top chord and the bottom chord integrity is far more important than the web. And because of that, in that kind of middle of the joist, you can cut holes in it. So this wall here, however, no header, no squash blocks. So that suggests a non-load bearing wall. And man, they did not leave much in terms of that wall there. Continuing out, you see that elevated rim joist header. Now, they also have this diagonal lead-in bracing, which I find very interesting. It's attached down at the plate. I don't see much attachment along the board there, and it is attached at the top. Not as tightly knit as I would want to see it, and then you can see it here again. There. Now, some of you might sit there and say, well, are they just leaving that like that? And the answer is yes, because you can see this wall is designed here to stand in front of it. So what we don't see that's happening, I'll come around the corner here and explain it. All right, so we have this cavity here. It's roughly the 6-inch or 5.5-inch cavity. This will get filled with a batt insulation, and then they put a poly sheet over it as their vapor retarder, and I want to say kind of loosely installed air barrier, although they do tend to seal it around it. But then what they do is they'll come on front of that and they'll run horizontal strapping and railroad it in and create a raceway. So as that comes around and goes around here, it's just going to fall in line with this plane. So those pieces will just go in across here and attach somewhere below that. So this basically gets buried in that furring. Now, I think the reason they leave this unscrewed is, and that's screwed and not nailed, is so they can back that screw out, pull this out, and slide that sheathing inside there and apply that a little later. At least that's what I'm hoping they would do. You can see this is the mechanical room. Mechanical room's got a drain and got a whole lot of pipes coming in. This is pretty interesting that it's kind of a piece of flex. I want to say, well, there's flex there, but that's some kind of insulated flex, and I'm guessing that acts somewhat like a muffler as they go through that system. Anyways, and of course, you can finish. These are your standard tilt-turn windows. So that pushes out. And it doesn't need to be egressed because there is a door here. So that one is just a simple hopper. Anyways, taking a little view here. There you have it. Some multifamily housing somewhere in Norway. It's the basic architect, you know it. Long live our buildings.